you miss anything. Okay, so first of all, these are the different types of inequality symbols that you have. You want to know these. If you're going to study like computer programming or something like that, it's a big deal that you understand inequalities because they show up everywhere in computer code. They're all over the place. Okay, so the typical symbols are less than or equal to, greater than or equal, and not equal. We call those inequalities because it means two things are not equal, versus having like 8 equals 8. Okay, that's an equality. Okay, so, okay, here's like 5 is less than 8. Okay, that just means 5. I put my Pac-Man on there just for something different. Okay, so the idea is the bigger number goes with the opening symbol right there, right? Okay, sometimes teachers will say that Pac-Man, if you even know what Pac-Man is. Does everybody know what Pac-Man is?
Yes.
I don't know about the of course. I've had some students who, what? I mean, I only know modern video games. This is back like in my day. I mean, this is like ancient video game. So anyway, that's the bigger goes there. The next one, if we say 1 is less than or equal to 2, we're, again, the bigger number it's opening up towards that. But the difference is something like this. If you had 2 less than or equal to 2, that's also true, isn't it? Okay, because they're equal. It just means it can be either less than or equal. So that would be a true statement. And if you had 2 less than or equal to 3, that's also a true statement, right? But if you had 4 less than or equal to 3, that's a false statement, right? Okay, so the equal to allows for equality, okay? What if you had something like 8 is less than 8? Is that true or false?
8 is less than 8. It's false.
It's false, of course. It's got to be equal to, okay? So basically, that's the difference between the two symbols. If it's got an equal to, it allows for the two numbers to be equal. Otherwise, they can't be equal. Does that make sense? Okay? And then it just goes the other way. If you got 3 greater than 2, okay, Pac-Man eats the 3, like that. That's an upside down Pac-Man. Okay? 4 greater than or equal to 0 works the same way, like that. That's the idea. Okay? Now, why I put a heart on that when I have no idea. Oh, that's Miss Pac-Man. For whatever reason, I must have put Miss Pac-Man on there. Okay, so not equal to just means two things are not equal. Okay, so if we have not equal, we put a line through like that. So you want to know what those individual inequality symbols mean. That's real important for understanding when you do inequalities. Okay, one of the things I want to talk about, just because a lot of times at this level of the class, students are wondering, well, what is this used for? If you're going to get into computer program, has anybody ever learned a computer language in high school a little bit? You learned about if-then statements and stuff like that, so you use inequalities a lot. So here's an example of kind of how a computer code might work. Okay, this is not an exact language, but you might have something like, if I was assigned, when I assign your grades, a computer program is doing all the work for me behind the scenes, is inequalities. So there might be a statement that says, if your grade, that's like a variable, okay, is greater than 90, then I'm going to output that you have an A in my class, okay? So what happens is, if the grade was 91, then it would ask the question, 91 greater than 90. Is that true or false? It's true. So the way computer code works on an if-then statement is if it's true, if that statement's true, then it goes ahead and just goes past the then and does whatever it tells you to do. If it's false, it goes to the next line in code. That's the way it typically goes. So if that one would be true, you would get an A. How about this one, 89 greater than 90? You're out of luck. That's false, so it would just, you wouldn't do what's after the then. Okay, how about 90 greater than 90? Is that true or false? False. So you wouldn't get an A. The only situation would be that one right there. So that's, you use computer code inequalities constantly. It's one of the big things that a computer understands. It understands how to add, subtract, multiply, and divide and do inequalities, but not much else. It's just the way that you put together the code that can get it to do so many things.
So you got 90 together, it must be like greater than or equal to.
Yeah, exactly. Like this one, if I change the statement to grade is greater than or equal to 90, then you would get an A if you had a 90, right? Because it would be okay. If 90 is greater than or equal to 90, that's true because they're equal. So see, you could adjust the computer code by doing that. Okay, that's how you use that too. Okay, so let's look and see kind of from our background what we know about not absolute value, but just basic inequalities. And I want to kind of look at what I want to show you on this. These are the possibilities. So if you have something like x is less than a, I'll give you an example, like x is less than 2. Okay, when you do this graphically on a number line, and we'll go through this, and you may or may not have had this, less than means you're going to the left, right? Left, right? Left. It means you're going to the left. So the idea is all the numbers that are less than 2 fall to the left of it. So if we draw a graph on a number line, we do that, and we do a parenthesis unless there's an equal to.
You said less than always goes to the left, right?
Right. Yeah, less than's going to go to the left, okay? Greater than's going to go to the right, okay? This one right here is x less than or equal to a, so if you had something like x less than or equal to 2, you'd still be going to the left, but you use a bracket. Why do you use a bracket? Because there's an equal to bar, and what that does is that includes the endpoint, okay? That's how that goes. And then we have interval notation, which I'll kind of talk about as I do examples on this. Basically, if you have a number line going to the left, then infinity's on the left. This is the symbol for infinity, but if you're going forever to the left, you use negative infinity, comma, and then you stop like this. So if you were doing a graph, just pay attention to this. You don't have to write this down. If you were graphing x is less than 2, here's what you would do. You would put a parenthesis on 2, and you would shade to the left. And all you're doing is you're showing me all the numbers that are less than 2 are that way, right? That's it. Yes?
What does the parenthesis versus the bracket mean?
Okay, the parenthesis is going to be used when you have the less than or equal to. If you have the equal to bar, that includes the endpoint. If you don't have the equal to bar, it does not include the endpoint. Some of you may have seen this in high school. Maybe you saw open bubble, solid bubble. Did any of you see that? It means the same thing. The solid bubble is just the bracket. Higher math, you never see it written any other way except parentheses and brackets. Just kind of depends on the textbook. And see, if you did this in interval notation, you always have beginning, end. Okay, this thing goes forever to the left, so you put negative infinity on the left, then it stops at 2. Okay, that's interval notation. What that's saying to a educated person is 2 in this way. That's what that says. Okay, it's just naming what the graph does. If you had x is less than or equal to 2, well, then it would go like this. Okay, what you would do is you would do a bracket this time, and that means that 2 is a solution to the problem. 2 is included. If you did the interval notation, you would go, okay, forever to the left, comma, and then ends in 2 includes 2. Now notice in that case I didn't put a bracket on infinity, and you never do. Because in order to use a bracket, it has to be a definite stopping point. It's got to be a definite number. Infinity's not even a number, is it? It's a concept. So you never, ever will see me doing anything like putting a bracket around infinity. You don't do that. It doesn't make any sense. Okay? So no brackets on infinity. Okay? Then if you get to the greater than, well, what's the only difference between greater than? Well, how are you going to shade? You're going to shade to the right. Okay? If it was greater than or equal to, what would be the difference? Use a bracket. That's it. Okay? And that's how you do that. And then when you do the interval notation, the infinity is on the right because you're going forever to the right. So notice in your interval notation, it goes like that. So just think of it this way. If it's less than, it's this way, from your perspective, negative infinity, comma, where it ends. If it's greater than, it's going this way. So it starts, comma, forever, like that, okay? So you want to try to get that in mind. Now, we're going to do enough specific examples. I'll give you time to practice this a little bit today, too, because this is super important for what we do in this section. Okay, so let's go ahead and let's fill these things out as we go. Now, all I want you guys to do on this is just put a 0 and then a 2. You don't have to do 1, 2, 3, 4 forever like that. There's no sense to waste your time on that. Just do that, and that's good enough. Okay, this is a less than problem, so which way am I going to shade?
Left.
Am I going to use a bracket or a parenthesis on the 2? Parenthesis. When do you use a bracket? Equal to bar. Okay, so you're going to put a parenthesis there, and then you just shade to the left. You do have to put an arrow there. That's important that you do that. Okay, that's how that goes. All right, now let's just do the graphs, then we'll go back to interval notation. Let's just get the graphs out of the way. Okay, the next one is greater than. So what I'd want you to do is just put 0 and then locate negative 3. Okay, how do you graph this one since it's greater than? To the right. Do you use a bracket or a parenthesis? Parenthesis. So you put a parenthesis, and then you shade to the right like that. Okay, so that's how that one goes. Okay. Okay, the next one is less than or equal to 0. So if you did this, I would just put like a 0 there. How are you going to graph less than or equal to 0? To the left with bracket or parenthesis? Bracket. It's got an equal to bar. So you're going to go like this, right on the 0, and then forever that way. All that's doing is it's showing you where on the number line numbers are. Hold on. That's a less than. Why in the world did I do what I just did? We need to go to the left, okay? Okay? Because that one says it's less than or equal to 0. So bracket on 0, and then that one, okay? All right, now the next one, let's see. We'll put like a 0 here. 1, 2, 3, negative 4, and then negative 5. So negative 4.5 is going to be halfway in the middle of negative 4 and negative 5, right? So which way do I shade? It's greater than, so what is it? To the right, bracket or parenthesis? So put your bracket right in the middle where the negative 4.5 would be, and then shade like that. Okay? So see, it's real simple. If it's greater than, and the x has to be on the left side. If it's x greater than, you're going this way. If it's less than, like these two are, you're going that way. Okay, does that make sense? And the difference between bracket and parenthesis. Okay, now let's do the interval notation and kind of get that out of the way. So here's the way that I look at interval notation. Okay, you always have two things. Okay, if you're going to the left, then you're going to put a negative infinity to begin with. Okay, we have two problems here that are less than problems. And they always start with negative infinity. Okay, that's what left forever is. Then this one would stop at 2, then we'd put a parenthesis. Okay, see, it didn't have a less than or equal to, that's why we use parentheses. Okay, and then the next one you would have 0, but you would use a bracket. So that's how that goes. On a less than problem, that's how your interval notation goes. Negative infinity, comma, where it ends. Okay, now did everybody catch why I used the bracket on example 3?
Because it's greater than or equal.
Yeah, it's got an equal to bar. That's it. That means that 0 is included in the solution. Okay? All right? Then the greater than goes like this. Okay? You would start at negative, this one starts at negative 3, then it goes on forever. So if it goes to the right, infinity's on the right. Okay? And then the last one here would go like this. Okay? You would have start at negative 4.5 with a bracket, and then go forever like that, okay? You want to make sure you have that in mind, so it's real simple again. If you go to the right, the graph goes to the right, where's infinity? On the right. If you go to the left, where's infinity? On the left. That's it. Is that logical? Have most of you seen that before? I have no clue when I teach this class. Okay, this is going to be something that you're going to do frequently when you're working with inequalities. You've got to know how to graph and write interval notation. Yes?
When you're drawing the line, does it matter if the line actually goes all the way across? Or
No, you just need to have like bracket and arrow. Okay? You got to show that arrow. The fact that it goes all the way to the end doesn't matter.
Yeah.
I just kind of what I'm used to doing. I just draw an arrow. But you have to draw an arrow. Okay? Okay, so let's do, there's one other kind of inequality you want to look at.
Can you go back for just a second?
Mm-hmm. Yep, I need to be there. That's what I just did. Okay? Yes?
So when you're writing an equation, if it has a bracket, I can't really see from here. So if it has a bracket, you do one side of the bracket and the other just put in parentheses.
Yeah, the thing on this is, remember I said infinity never has a bracket around it. Because a bracket means that you're coming to a definite ending point. Okay? And negative 4.5 is a definite ending point, but infinity isn't. So when you have that equal to bar, you're going to use a bracket, but it's only going to be on the number. It'll never be on infinity. See, the idea of like with this one right here, x is greater than negative 3, you could not tell me what number comes after negative 3. Because it's like, what is it? Negative 2.99999 forever. Okay? It doesn't come to an end, so that's why you put a parenthesis there. Okay, but don't ever put brackets on infinity. Does that answer what you're...
Notation, it has to have
It has to have the bracket on one of the numbers,
okay, yeah.
but never the infinity, never ever, okay? All right, you got everything that you need, okay? All right, so let's do these things we call in-between inequalities, and what this does is this. I'll just kind of talk you through this. This is basically, anytime you see two less than symbols, what this is saying is it's saying x is between -2 and 5. It's in the middle of -2 and 5, and it does not include -2 and 5. The reason it doesn't include is because those less than symbols don't have equal bars under it. So that would just be saying every number between -2 and 5, but don't include -2 and 5. So that would be an infinite number of numbers because there's decimals and fractions, right? Okay, so you write it that way. This problem right here says all of the numbers between -3 and 10, but which one is included? The -3, okay, because of the equal to bar. So you include the -3, you don't include the 10 because it doesn't have the equal to bar. You see what I mean? Okay, so see, if I said, is 10 a solution of that inequality? It's no, because if you put a 10 there, 10 less than 10 is false, isn't it? So that's not an answer. But if you put -3 there, you're good. -3 is equal to -3. You see what I mean? So there's a difference between including and not including, and in computer programming, that turns out to be a huge issue. You wanted it to either include or not include, okay? So this is kind of in general what you would have here. So the idea would be if you had something kind of like, and this set builder notation, whenever you see me write those sets, that just means it's a solution. What that's saying is it's all the numbers between A and B not including. So when you draw a graph on it, your graph's not going to go forever in one direction. It's going to have a beginning and an end. So in this case, it has two parentheses and it's everything in the middle, okay? If you had this, if you had A less than or equal to X, less than or equal to B, X is in the middle of two numbers. So you're not going to go forever. You're going to have a beginning and an end. And they're both going to have brackets. Why? Because they both have equal to bars, right? That's why. Okay, so that's how that goes. Then the interval notation is going to have brackets on both. You don't have any infinities in these in-between inequalities. They're in the middle. Okay, this one is going to be in the middle of A and B. Why did I put a bracket on A? Equal, it includes. Why did I not put a bracket on B? There's not an equal to bar on that, see? So that's the idea. Okay, so I'm going to do some problems kind of like that. That's just more of a summary. I've already done this, so I don't know why I put this on here again, but the idea would be 90 greater than 90. Would you get an A according to that statement? If the grade's 90, that would be false, right? So did you get an A? No. How about if it was 91? Yes. Okay, like that. So and the reason I'm doing it, I want you to know at least some place where inequalities are useful. That's a big, big place. Okay, so we're going to kind of start with absolute value less than inequalities, kind of like this. And what I want to try to introduce you to do is how you do an absolute value inequality. What we did in the last section in 2.6 is we were doing stuff, and you don't need to write this down, we were doing equations, right? Typically we got two answers, most of the time. Now we're going to do an inequality. If I change that to like less than 6, then we end up having, most of the time, an infinite number of answers, okay? So I'm going to have us kind of reason out to help you understand, because if I just show you the how-to part, that won't do you any good, because you want to understand why the answer is what it is. So this is what I want you to do. On the number line I gave you, I want you to put a 0 and then put a 3 and then put a -3. You don't have to label all those numbers except the 0, the -3, and the 3. Now we're going to see, we're just going to list out numbers that would work and list out numbers that don't work. Okay, I'm going to start, and I'm just going to show you my logic on this. I'm going to replace X with something, like a 0. Okay, would that be true? 0 is less than 3. Yeah, let's write that down. That's a solution. 0 is a solution, without a doubt. Let's keep going. I'm only going to do whole numbers. Let's go to 1. Is that true? 1 is less than 3. Now I'm doing the absolute value of 1, but that's 1, isn't it? That's an answer. Okay, I'll keep going. 2. Is 2 an answer? Yeah, 2 is less than 3. See, I'm really doing absolute value of 2 less than or equal to 3. So that's an answer. Let's go to 3. 3, absolute value of 3 is less than or equal to 3. Is that true? Okay, it is. So that's an answer. Okay. All right. Let's go to 4. All right. Let's see what happens. Okay, if I put a 4 there, is that true? No. So see, what's going to happen is once you get past 3, does it make sense that nothing's going to work anymore? Okay, but that's not all the answers. We need to go to our negatives and we need to see what happens. Okay. All right, so let's continue to kind of think about this. Let's go with -1 now. Okay. So if we have -1 less than or equal to 3, is that true or false? That's true, because it's really saying 1's less than 3 because you're doing the absolute value. Okay, well, -1's an answer. Okay, let's go to -2. Is that an answer? Yeah, that's an answer. Okay, let's go to -3.
Yes.
Is that an answer? Yeah, because it's equal, right? Okay. Now let's be careful on this now. Now let's go to -4. Is that an answer? See, that's what you got to understand. What is the absolute value of -4? 4. Is 4 less than 3? No. So what happens is, once you get below -3, they don't work anymore. So what you find is all the answers on this problem are between -3 and 3. Okay? Once you get past 3, it's not less, the numbers aren't less than 3. Once you get to the left of -3, their absolute value is not either. What this problem is really saying is it's saying, give me every number that has a distance from 0 on a number line less than 3. So all the numbers between -3 and 3 are less than 3 units from 0. That's what that problem says. So what you would do on your graph is you would do this. You would put a bracket on -3, a bracket on 3, and you would shade in the middle. It's only the numbers in the middle, so you would go like that. Okay, that's how that works. And then for interval notation, now interval notation is kind of start, comma, finish. There's no infinity. Where does it start? -3, where does it end? 3. So you write the interval notation answer as -3, comma 3 with brackets on both. And that's how you reason that problem out in your head. And that's the way I'm going to start out, is because it'll help you understand the problem. Okay, that's what that means. Okay, and what we're going to focus on is just absolute value less than inequalities. And what's going to happen is, if you have an absolute value that's isolated, less than a positive number, then it's going to be between two numbers. It always will be. You're not going to be going on forever that way and forever that way. It doesn't work. And it's because of the absolute value. So that's what you're going to see. So I'm going to run down to number 8. I'll kind of, the rest of that stuff below that is stuff for you, for your guidance through the problem. So what we're going to do on this one, this is how you learn to do an absolute value. Now I'm going to show you the how-to part. Anytime that you see an absolute value that's isolated, less than a number, a positive number, you need to know immediately the answer is between two things. Okay, because it's always going to be that way. So what you do in this case, that absolute value is already isolated. So what you do is just write x down, ignore the absolute value, and put it in the middle of 2 and -2. Okay, and then put two less than symbols. Don't put greater than. By the way, why do we do less than? Well, which number is smaller? This one. We say -2 is less than the answer, but then that's less than 2. So what you're saying is x is in the middle. That's another way of saying x is in the middle of those two numbers. Okay, we don't say greater than because that is less than that. Does that make sense? So I always use less than symbols. Okay, so it goes like that. So here's what you're going to learn how to do when you write in set builder notation. First thing you do is you put a set brace. So it's just a brace. Then whatever the variable is, you put an x. And then you put a bar. I'll explain what that means in just a minute. Then you just write down what I wrote down. -2 is less than or equal to x, less than 2, and then you close the brace like that. That's called set builder notation. Okay? Now what this means is this set symbol is saying set of. It's an abbreviation for the word set of. X is like just X, or it's just some number. The set of numbers, and then that bar you see me write, that's a shortcut in math for such that. So what that says is it's the set of numbers such that it's between -2 and 2. That's what that says, okay? Now for a graph, what you would do on the graph is you would just want 0, you would want to locate 2 and -2, and then you would want to shade in the middle of them. Okay, now this time you're going to use, what are you going to use, brackets or parentheses? Brackets. You're going to use 2 brackets. Bracket there, shade in the middle. Do not go past those brackets. Your answer is in the middle of those 2 numbers. Okay, and then as far as the interval notation goes, it's just like the number line. You start at -2, comma, end at 2, include 2. That's what you're trying to learn how to do. That's a real simple one. The idea is you know that it's between 2 numbers, so you can automatically jump there. If that was a 3, what would be the difference? -3, 3. If that was a 4, -4, 4, and so forth. That's it. Okay, does that make any sense? Okay. All right, I want to try to finish up class by getting through most of the less than problems, but that's all I'm mainly interested in today. Okay, so here's what you do. First of all, the first thing that you want to do is you always want to ask yourself, is the absolute value isolated on one side? Is it yes or no?
Yes.
Okay, does everybody understand what I mean by that? There's nothing in front of the absolute value, and there's nothing on the other side. So the idea is isolated is absolute value, nothing there, nothing there. Okay, so you're isolated. So then what you do is you set up an inequality, and you kind of set it up in between 2 numbers. Since it's less than, you know it's in between. So here's what you do. You just write down 4k plus 3, this time we have k, and then you put it in the middle of 6 and -6. Then you're going to put 2 less than or equal to symbols like that. Now what we have to do is you have to solve this inequality. It depends on your background. What you have to do on this is you've got to get k by itself in the middle. That's not done. So how do you get rid of that 3? Subtract. You'd have to go minus 3 there, -3 there, and -3 there. This is called the 3-part inequality, so you have to do the same thing to all 3 parts. That's real important, okay? All 3 parts you have to do that. So what you're going to have then is -9 here, less than or equal to 4k here, less than or equal to 3 there. Okay, then what? What's logical? You got to get k by itself, so how do you make it happen? Divide by 4, exactly. And you got to divide everything by 4 like that. Okay, now see, that would be what you'd be ready for now with the solution set. So you set it in the middle of the 2 numbers, the number and the negative, and then you get the variable in the middle. So when you write set builder, set brace is what you do first. Put the variable is not x this time, it's k, and then put the bar. That's saying the set of numbers k such that, and then these fractions don't reduce, they're already reduced. You don't need decimals, so just write it like that. Okay, now that gives you that. Okay, now if you're going to do a number line, it makes a lot of sense when you're doing a number line, and you don't have to really, but if you took like a calculator and did -9 divided by 4, you would get like -2.25. Okay, and then I don't know why I put a k there, that's 3/4. 3/4, if you used a calculator, it's 0.75. Okay, so the way that you would do your number line graph on this is have a 0, have a 1, and then probably go out to about -3. Okay, and then what you're going to do, this one is less than or equal to, so you're going to have 2 brackets. So you would have a bracket, that's about 75% between 0 and 1. -2.25, you'd be a little bit to the left of -2, then you'd have that like that. Okay, so that's how your graph would go, is like that. You got to estimate where the decimals fall. Okay, then the last thing that you would have is when you do set builder notation, it's just this. It starts at -9/4, comma, see it starts there, it ends in 3/4 like that. So that's how you write the graph and then the set builder and interval notation. Those things are interchangeable. When you're doing your homework, it's generally going to say write interval notation, graph, and it may also sometimes say solution set. Okay? All right, now I want to finish up class by showing you why this is right. Okay? Now, to me, the key, and you'll hear me saying this during the semester, the key to understanding math is to understand if you're right and why you're right. If you don't, you won't understand anything. So here's what I want, and I want you to write this down because this is pretty important, is what we're going to do is we're going to check the answer to 4k plus 3 in absolute value less than or equal to 6. And we're actually going to check these endpoints. And then I'm going to check a number in the middle. So one thing that it's kind of good is just kind of get this built. Then this will hopefully help you understand what this problem means anyway. Okay? So what are our endpoints? One of our endpoints was -9/4. So let's plug in a -9/4, and don't freak out about the fraction because it's going to cancel anyway. What happens to those 4s? Cross out. Okay? So that's what happens. Okay, so look what you're left with. You're left with -9 plus 3 less than or equal to 6. Okay? What is this going to be? -6, but when you do the absolute value, what are you going to get? 6, right? Okay? You don't have to write that step because I'm just trying to see that you can do this in your head. Okay? That's true, isn't it? 6 is equal to 6. That's a check. That means the endpoint's right. Okay? What's the other endpoint? 3/4. Plug it in. See if it works. So if we plug a 3/4 in, those cancel out. Okay, just a second. That's 3 plus 3. Is that right? Yeah, because 3 plus 3 is 6, and 6 is equal to 6. So that's right. So the endpoints work, yes.
So on the first part of doing this problem, you got the absolute value 4 is that -4/4?
Yeah, this right here.
Yeah.
Yeah, what I was doing is I can cross out, when I multiply fractions, I can cross out something that's in the numerator with something that's in the denominator. Okay, like that. Okay, now I want to ask you guys this question, okay? Look at my answer. Give me a number, and make it easy for me, that's between -9/4 and 1. Give me a real easy number that's in the middle of -9/4 and 3/4. 0. I love 0. It's my favorite number to calculate with. Okay, let's plug it in. Let's see if it works. What is that now? That's going to be 0 plus 3, so that's 3, isn't it? Is that true? Yeah, okay. So every number in between in that graphed interval would work. Every number outside of that would not work. Okay, does that make any sense what I'm trying to show you? You can take the endpoints and plug them in, and if they work, you're good. And then maybe just take one number in the middle and make sure it works. Then you got it. Okay, yes. What I was asking was I wanted you all to give me a number between here and there. Somebody said 0. Okay, you could use -1 if you wanted to. You could use -2. The point is, everything in that shaded region would work. Okay? All right, very good. So we'll bring this class next time, and we'll wrap this up next time. Get that video. Watch that video. I think you'll like it. Shouldn't take that long. Just kind of write about what you liked and what you thought.
Actually, well, yeah.
Yep.
2.7. So I was trying to answer it last time.
Mm-hmm.
Do you necessary, is it necessary for you to have to put the brackets and everything? It has to be complete, as you showed us last time?
You mean you're talking about the homework?
Yeah, the homework on 2.7, because I got a question and I put the answer, like I know what it was talking about, but in my other class they didn't show us about the brackets and stuff, so it told me it was wrong. And
Yeah, you got to have.
put like everything like how you showed us.
Yeah, usually what my math lab for 2.7, they're going to have the graphs as multiple choice.
Yeah.
There'll be 4 choices.
Yeah.
And they'll always have brackets or parentheses.
Okay.
So you want to be sure that some people do open bubble, solid bubble. You want to change to bracket, parentheses.
Okay, got it.
Okay.
Yeah, because I was doing it and I was a bit confused. I was like, well, I understand what they're trying.
Yeah.
Like, I have the answer. The only thing it was like I wrote it down in the box and it was like, oh, it's wrong. And then now I got it. Like,
Thank you.
I have to like put all the brackets and stuff, right?
Yeah.
Yeah. Okay. Thank you.
I put my school email on there.
Okay.
They're talking about for these numbers to
Yeah.
get into my math lab, I think. Can you email me?
Yeah, I can. Yeah, definitely.
It's just
Usually it takes.
a day or two.
Yeah, it does. So if you enrolled Friday, that
did
would
it like
that would
Friday
make
at
sense why you're not there.
Like 3 o'clock.
Yeah, that's fine. You'll be in there.
I just want to say thank you for working it off.
What's that?
I just want to say thank you for taking it off. It was a good class.
Oh yeah.